Hey ladies and gentlemen, this is Miss Humbert. Today we're going to be talking about the second part of your Unit 8 notes, which is talking about extraneous solutions. So sometimes you get a solution that is derived from an equation that's actually not a solution of the original equation. So we've talked about with radicals how if a radical is set equal to a negative number, then it has no solution. So what we're kind of doing today is we're looking, because sometimes you get two solutions to an answer. So we're going to be plugging things back in and making sure that all of those solutions work. And so we're going to kind of be doing some factoring. We're doing a little bit of everything today. And so make sure you get your brains in gear for this. So let's take a look at number 9. Okay, so we've talked about how to undo a radical. We need to square both sides. So I'm going to start by doing that. So to undo a radical, I need to square it. Now, the only time I can square when we're solving equations is if the radical is completely isolated on one side, which if you look in number 9, it is. So I'm going to go ahead, and what I do to one side, I have to do to the other. So I'm going to square this side, and then I'm going to square that side. Well, when I square the square root, that just leaves me with x plus 2 on this side. And then I'm going to square the other side, which leaves me with x squared. Now here's the deal, okay? I like to make my life really easy. I have a squared term involved, so I'm either going to have to factor or I'm going to have to use the quadratic formula. Either way, my life is a lot easier if the squared term has a positive coefficient of 1. So for that reason, I'm going to subtract x and 2 from both sides. So I end up with 0 is equal to x squared minus x minus 2. Okay, so I know how to solve it. This is something we've seen a lot in our algebra A. So what I'm going to do is I'm going to set it up for factoring. So because my A is equal to 1, I can use quote unquote easy way factoring. So I'm multiplying to -1 and adding, or sorry, multiplying to -2 and adding to -1. Now to do that, I'm going to use -2 and 1. Because my A coefficient is equal to 1, I can immediately put that into factors. Now, unfortunately, right now, I am far from done. Both of those factors are multiplied together are equal to 0. So now I can use that zero product property. So I can say, okay, either x minus 2 is equal to 0 or x plus 1 is equal to 0. So I'm going to solve out each of those equations for x. So I get x is equal to -1 here, and I get that x is equal to 2 here. So here are my two solutions. Again, I'm not quite done yet. What I actually have to do with each of those solutions is plug them into the original problem. So I'm going to do that right now. So I'm going to start with -1. So I'm going to have the square root of -1 plus 2 is equal to -1. So then I get the square root of 1 is equal to -1. Well, technically the square root of 1 is 1, but we can't have a radical equal to a negative number. We talked about that earlier on the note sheet. So -1 can't work because we have a radical set equal to a negative number. Now let's try 2. Okay, so now we're going to have the square root of 2 plus 2 is equal to 2. So we get the square root of 4 is equal to 2. Square root of 4 is 2. 2 is equal to 2. That does work. So our only solution for that one is that x is equal to 2. Let's take a look at number 10. Again, same thing. My radical is already isolated on one side, so I'm going to go ahead and I'm going to square both sides. When I do that, I'm left with 4x minus 3 on this side, and then x squared is just going to give me x squared. Again, I want to subtract those to go to the other side because that's going to end up making my life a lot easier. So I'm going to subtract 4 and add 3 to both sides. I need one side equal to 0 in order to solve this, and that's why I'm doing that. So then I end up with 0 is equal to x squared minus 4x plus 3. So now I can use the x to solve that. Okay, I'm just going to erase this and get it out of the way. So we're going to go ahead and solve that. So we're multiplying to 3 and adding to -4. So we're multiplying to a positive product and adding to a negative sum. To multiply to a positive product, both our signs have to be negative. Okay, and then that's how we add to a negative sum. So I'm going to use -3 and -1. Again, my squared term has a positive coefficient of 1, so I can immediately put that into factored form. And that's set equal to 0. So now I'm going to use the zero product property to solve this. So I'm going to do x minus 1 is equal to 0. And x minus 3 is equal to 0. So when you solve those out, you end up getting that x is equal to either 1 or 3. Again, we're not done. We have to check to make sure those solutions work. So that's what we're going to do right now. And I'm just going to erase this to kind of get it out of our hair a little bit. Okay, so now I'm going to check that in the original problem. So for the x, for example, I'm going to do that over on the left here for the 1. So I'm going to do the square root of 4 times 1 minus 3 is equal to 1. Well, the square root, 4 times 1 is 4, and then minus 3 is equal to 1. So we get the square root of 1 is equal to 1. Well, the square root of 1 is just 1, so 1 equals 1. Hey, that works out for us. So we know 1 works, but we still have to try 3. So then I have the square root of 4 times 3 minus 3 is equal to 3. So my radical is set equal to a positive number. That's a good start. So then I get 12 minus 3. 12 minus 3 is 9, so I get the square root of 9 is equal to 3. Well, the square root of 9 is equal to 3, so 3 is equal to 3. Well, looky there, both of them work out. So both of those are an answer to our equation. Let's take a look at number 11. It says find the perimeter of a rectangle is 20. The dimensions are 4 and the square root of x minus 1. Find the value of x. So let's figure this out. So we're looking for the perimeter. Okay, so the perimeter is 20. To get a perimeter, you need to add up all of your sides. So we have two sides of the rectangle that are going to be length 4, and we have two sides of the rectangle that are going to be x minus 1. So I'm going to go ahead and write out each of those. That should be x minus 1. That kind of just looks like 1, or a plus sign, doesn't it? Okay, there we go. So now I'm just going to go through, and I'm going to kind of add this together. Well, 4 plus 4 is 8. And then I can actually, just using what you guys learned about adding and subtracting radicals, I can add those two radicals together because they have the same thing underneath. So then I get 2 square root of x minus 1 is equal to 20. Now I'm going to go ahead and I'm going to solve this for x. So I'm going to start and I'm going to subtract 8 from both sides. And then I get 2 square root of x minus 1 is equal to 12. And then I'm going to go ahead and I'm going to divide both sides by 2. Remember, we don't want to square that radical until it's completely isolated. So we get the square root of x minus 1 is equal to 6. Now that that radical is completely isolated, I can go ahead and I can square both sides. So that's what I'm going to do. When I square a square root, I'm left with x minus 1 underneath. And then I get 36. Now I'm not completely done because I have to solve all the way for x. So I'm going to add 1 to both sides, and I get that x is equal to 37. So it asks us to find the value of x, which we did. So we're done on this one. Okay, let's take a look at this next one. In a proportion a over b is equal to b over d, b is called the geometric mean of a and d. If the geometric mean of 3 and a is 9, what is a? Okay, so what that tells us is that our b is 3. So this tells us that our b is 3. So we can go ahead and figure out our d. Okay, so we're going to go ahead and we're going to plug that in. So we're going to get a, or sorry, our d. This should say d. D is 9. So a over 3 is equal to 3 over 9. And now we're going to solve that using cross multiplication. Cross multiply, cross multiply. So then I get that 9a, because I'm going to do 9 times a, is equal to 3 times 3, which is 9. So I'm just going to solve that by a, for a, divide both sides by 9, and I get that a is equal to 1 for that geometric mean. And that concludes your second video. Thanks for listening.